Good day. So in this tutorial I am going to draw the assembly of the knuckle joint, and this is the assembled drawing of knuckle joint. And in this knuckle joint there are 5 components: fork end, taper pin, collar, pin and eye end. So these are the 5 components of the knuckle joint. And in this the left hand side, these two eye fork end, this is the fork end and this one is the eye end, and we have a center pin and a collar here and a taper pin is here. So these are the 5 components of the knuckle joint. And in this knuckle joint, the main application of the knuckle joint is the transmission of the tensile force, and one shaft can be connected to the eye end and another shaft can be connected to the fork end, and these two shaft is connected using this knuckle joint, and these two shaft will be under tension, and some flexibility in the angular direction also allowed in the knuckle joint. So that is the important applications of the knuckle joint. And for drawing the knuckle joint, first I am going to draw the this fork end, then eye end, and then remaining components, then I will assemble the components. So for drawing the fork end, I am drawing that this is the front view of this assembly. Okay, this is the front view. So I am drawing the front view of this fork end. So this is the front view of the fork end. So that is I am going to draw. So in this I am taking a new drawing with the fork end, that is the file name, fork end. I am not using a default template. Then press OK. So fork end 1, that is the okay. And then this is the MMNS part drawing is the template I use. So this is the drawing screen. So here in this, my front plane is this one. So in that I am going to draw, because I am drawing the front view of the fork end. Then so here in this we have at the center, based on the center we can draw 2 circles with the radius 14 and the radius 32. So initially I am going to draw 2 circles. So first circle, then second circle, and dimensions are, so first this is, here it is diameter, here it is 32 radius, that means 64, and here 14, that means 28 diameter. So 64 and 28. Here this is 64 and this is 28. So we draw 2 circles. Then here from this center to this axis the distance is 29. So I am going to draw the axis from that center. So using this line in a construction mode, I am drawing a vertical line, and the distance between these two is 29. Okay, 29 distance. So it's already given, this distance is 29. Okay, then we have a horizontal portion here from the circle, and that distance is 28. That means from the center it is 14, and in the downward direction it is also 14. So I am drawing 2 horizontal line with the 14 distance. So actually this horizontal line is starting somewhere, and this and this distance is equal to 40. total is 28, so it will be 14, and this distance also 14. There are some constraints in this, so I am removing this, and again horizontal. This distance is 14. Okay, so we got two lines, horizontal lines with the 14, and this distance from the end point to here up to the center axis, it is 108. So this distance should be 108. This is the center axis, so this distance is, sorry, and this is 108. Okay, so we can close this this portion, and we can remove the remaining portions, and here this area can be removed, and this area also can be removed. Okay, so we got some portion of the forehead, and then I don't know, so actually we have to, after extrusion, we have to draw a circle here. So I am extending this area further, so vertical, then here. Similarly here also I am extending further. Okay, so the front view of the forehead is completed. Then I can extrude this sketch. So how much I extrude here? It is given 28 rectangle. That means this dimension also 28. So I am extruding by a distance of 28. So this is equal to 28. Then press OK. So we got this forehead. Then in the top plane of the forehead, next I am drawing the circle. So in this forehead, so I am giving some references. Okay. So actually here, this is the point where actually the curve is up to this point. So after the curve, then means curve is up to this point, means this is the point, corresponding point. Then from here, 29 distance from here, we can draw a line, and in that I can draw a circle. So here I take a First I am drawing a rectangle here to find the midpoint. So this is a center line. Then here the distance, I am drawing a line. So that is at a distance 29. This distance should be 29. So with this point as center, I can draw a circle, and what is the circle diameter? Diameter of this circle is 48. So diameter of the circle is 48. So 96. Diameter. Okay, so it has to extend little bit, then only I can accommodate. Sorry, this is 48 because this is the diameter. So this is 48 now. Okay, so this is my circle. So after that I remove the remaining components. Actually this is not good. So this is my circle. Okay, so I have the remaining portions. So next I am going to extrude the circle. Okay. So then I can extrude the circle, and the extrusion is 18. Extrusion in the reverse direction by a distance of 18. So extrude. Then after that I have to remove the extra portions from here. For that, again sketch, then make all the edges as reference. Then draw the portions which we want to remove. Then we have a circle. So there is a circle. Okay. Then remove this area. So this portion we can remove. Then remove material in the opposite direction. So the bottom portion also can be removed by extending. You can remove the bottom portion also. Okay, then this portion, this extrusion can be mirrored. This portion can be mirrored with respect to the plane. Here the top plane is the mirror plane. So use the mirror option, then take the reference is select one item, then so again the extrude, this is going to mirror, select mirror, so I mirror the portion and I got the fork end. So after that here we have some fillet. So in this I am giving some fillet by a suitable. The same thing also can be no, not possible. Then in this end here we have a octagon shape in this end, so we have to create an octagon there. Then so select this area, sketch, then here take all the planes as reference. So when we select the reference, it turns to blue, then only we can pick the exact edge. Then from the palette we can take the octagon, drag and place somewhere, then press OK. Then using constraints, coincide constraint, select the center and select the center of, so here the center is not given, so how to draw a line, it should be construction line. A construction line is drawn to find out the center, then use coincident, so I coincide into the center, then coincide this edge and this edge. So there is a constraints, so this dimension is not already given, so we can delete that dimension. So we got final octagon. Okay, so we got this octagon. Then we can actually for drawing this one we have to remove this portion, so draw a line here connecting the corners. Then remove the unwanted lines. So here we don't need this one, this one, this one, and this one is not needed. Okay, and this one is also not needed. So we need only the edge portion for drawing. So we got this edge portion. Then we can press OK. See this, only the edge portions are selected. Then we can do extrude, so we can see clearly. So this is the only edge portion. So then we can do extrude cut. And how much distance? This is up to 30. So 30 distance, then press OK. Then in this area I am giving a round fillet up to this 5.10. Then here also select this edge, okay, it turns to green, then 5.10. Okay, so we create this portion, and if we need we can extend this some distance of shaft also by drawing a circle. So here also we don't know the exact center. To draw the center, we have to draw a construction line, so that is also not given. So one more reference is required. Okay, so draw a line here, a construction line. Then from this we can find the center. So this is the center. So then I can draw a circle here, and this circle is actually this much. Extrude by some distance not specified, then fillet this edge by pressing Ctrl. Then we can do the fillet operations here. Computer is a little bit slow. It's not clear. Okay. So after filleting, we completed the, and here at the center of this we need a hole for inserting this pin. So the diameter of the pin is also given. It is equal to 24. This is the end of this pin. So diameter is 24. So we need to drill a hole here. Sketch. Take this as a reference. Then only we can identify the center. then draw a circle. Okay, with the diameter 24, right? Diameter is 24. Then press OK. Then extrude the reverse direction, the total distance. Here we can give up to next surface. Sorry. Inside with all surface. So we finish this fork end. Then we can save this document in desktop. Sorry, in my documents. We can save this document or in desktop. Okay, or we can create a working directory. Here I am not creating any working directory, so it's saved in the fork and is saved. Next one is again part. The next one is IEnt. Not using default template. You have to use same template throughout the assembly, then only the dimensions are off. Then here in this select all. Then in this also I am going to draw this front view. Okay, so that is a 28 distance sketch on the front view. So here the total distance is from the center up to center, it is 96. So we can draw a rectangle with a 96. So I am taking this as a reference. Here this is 28, so this is 28. Okay, and this distance is 96. So actually total is 28, so this will be 40. Okay, so we got this mesh portion, then up to 96. Then I am extending up to a particular distance for drawing this circular portion. So I am extending some portion from here to left side to draw the circular portion. Okay, so this is not dimensioned, and this is for drawing the circular portions. Then press OK. And sorry, there are some extra lines. Edit definition. So you have to remove the center line. Then only we can extrude. Okay, press OK. Then extrude, that is also by distance of 28 distance. Okay, so we got 28 distance. Here also it's 28. So 28 distance extrusion is over. Then Then in this top plane, this is, I'm going to draw a circle. So here in this, I don't know the distance. Actually, center line is here. I think this is the center line, but we can measure that. What is the distance between these two points? 96. Okay, fine. So after 96, we extended some distance where I am drawing. So at this 96, we have to draw a circle. So here at the center, we will draw a circle. So I am drawing a construction line here to find the midpoint. Then draw a, sorry, change the construction mode and draw a circle with the diameter. Even this diameter also 48. This diameter also 48. Diameter is 48. Okay. Then we can extrude this the opposite direction by a distance of 8. This is also 28. This distance is 28. 28. Okay. Then again draw a sketch here to remove the remaining portions. Make all these points as reference. So we have to make this as reference, then only you can pick the exact points along the line or along the circle. Then draw the line for removing this extra portion. Draw a circle and remove this area. So we got this area, see this. So we can remove this by Extrude Cut. Up to 40. What is the thickness? 28. 28. So we remove, we got this portion. Okay, and here again we have to draw an octagon. So take this plane, sketch in this, again make all this as reference. This is the reference. Then draw a line to find the center. Okay, it's a construction line. Then after that, take from the palette octagon, drag and place here. Then press OK. Then take the center, go inside and select this line. Okay, again select the center, go inside this line. So it's come at the center. Then again, okay, one thing is that switch off this. First remove the construction mode, then only we can draw the, again take the octagon, then press OK, then take this and select the any of this line passing through the center. Okay, stitch this place. Again, take the center and take the opposite line. Just come at the center, then select this line and this line. So there will be error confliction. So delete these dimensions. We not specify the dimensions. Delete the dimensions. So we got the octagon here. Okay. Then draw lines in these corner points. Then maybe we can remove material from the corner points. Then remove the segments. So we got 4 corner areas. Then press OK. And again remove material. Extrude opposite direction. This distance is 30. This distance is 30, so give 30. Remove material. 30 distance. Press OK. Then take these 4 edges by clicking on Control. You can select 4 edges together. Change to green. Then round. Oh, it's not possible. Okay, round. Then distance is 6.10. Okay, 6.10. Then again select this plane. Then we are going to draw a circle. So here also we have to find the center. Make this as reference. Cross line here. Then draw a circle here. Okay, and extrude up to a distance. The distance is not specified here. Then the top area we have to drill a hole. Sketch. So the dimension of the hole inside this will be equal to the diameter of the pin, that is 24. So here again make this as a reference. Change to blue color. Then select the circle. Then this is equal to 24. Press OK. Extrude. Then extrude cut in the reverse direction up to extrude up to next surface. Okay, so we got the second component I end and save the next component I end. Again I am saving in desktop. Second component is over. Third component is collar. Again new document part default template. It's not default template. Then here I am taking this is. So throughout the assembly you have to select same template. Then so here in this I am going to draw this one. Okay, this pin. Sorry, not collar. You can draw so collar. Okay, so I forgot to give the name. It's not possible. So I am taking a new drawing. So closing this for collar. So here I am taking default MM as template. Then in this collar, this is actually I am drawing the circle which is the top view. This is the top view. So I am going to draw a circle in the top plane. Sketch in the top plane. So the circle diameter will be 36 and the outside diameter 24 is inside diameter. 36 and 24. This is 36 diameter and this one is 24 diameter. So we got two circles. So then extrude, and the extrusion distance is 12 mm thick. 12 mm thick. So we got collar. Save again. Collar part. Collar is saved. Next part is again sketch pin. Pin. Okay. Then select the template. So in the pin again I am drawing this top view. So this is 24 diameter. Pin is actually I am drawing. So take the top view, sketch. Okay. Then to extrude to a distance, we have to calculate this distance, and the total distance is equal to 6 plus 12. Total distance of the total dimension of the length of the pin is equal to 6 plus 12 plus 18 plus 28 plus again 18 plus, and this is 12 mm, so 12, so total 94. Sorry, 94. The one part is not required, that is this portion is again we will draw 12 mm thicker, so we have to remove that. So remaining portion is 82. Okay, up to this point 82. Then in this end we are going to draw the head. Sketch, and head is also a circular one. See this head with the 36 tall thick. So draw a circle with a 36 diameter, 36 diameter, and extrude 12 thicker in this direction, 12. So we complete the pin. And one more thing, inside the pin we need a hole for this taper, and that taper is 5 mm, 6 mm thickness. So we have to calculate this taper dimensions. For that, so this is my taper pin. I'll show the cross section of the taper pin. Okay, this is the taper pin. This is the taper pin, and here the diameter is given 6. So this is 6, and the length is given 42. This is 42. Okay, and the smallest diameter is, we have to calculate from this ratio, 1/50. The formula for this is capital D minus small d divided by L equal to the ratio, that is here 1/50. So 1/50. Okay, so here capital D is given 6, small d is given 42, and length is given 42, L, D is we have to calculate using this formula. So by calculation it is we found out that this is equal to 5.16. Okay, so for this taper pin, 6 and 5.16 are the dimensions. So we have to make a hole with the lowest dimension. Then only we can make a mating with the interference joint. So here I am making a hole with the 5.16 diameter. So here, and what is the distance? Actually, the distance should be at the center of this column. That means here it is 6 and this is 12. So half of the 12 is equal to 6. So 6 plus 6, 12. So from the top, 12 distance. So for that, so here I have to draw a first check the available planes. So here, passing through the center, we have a plane. So in this plane I can draw a circle that is passing through the center. So again, make the references, cross, then draw a circle, and it is 5.16, smallest diameter, and this distance is equal to 12. Okay, so we draw a circle at the center, then extrude in both directions. Here we have an option, extrude in both directions, and remove material, and the diameter is 24. So here, 24. We got a hole here. Okay, so we complete the pin also. Save again in the desktop. Save the pin. Then one more component, that is a taper key, taper pin. Okay, so the space is not allowed, so we have to give underscore. Then again the template. So here I am drawing the side view. So here we can see I am drawing the circle, which is a side view. The circle is a side view. So take the right side plane, sketch. You have to select the proper plane for the components, because during the assembly process and these planes actually intersecting. So we have to select the proper plane from the drawing. And taper, coming to the taper, already explained. Maximum largest diameter is 6, smallest one is 5.16 based on this ratio, taper version. So this is equal to 6. And okay, then extrude. There are different options are available. Here we have an option for tapering, but add a taper, and here it is angle. So but here using this formula the angle is not given, so I am using separate method, another method for drawing. So here I am drawing this taper using revolve. So I am drawing this front portion. Okay. So take front plane, sketch. Then I am drawing the front area of the taper. And using revolve feature we can make the taper. So this is equal to 6, half of 6, that is equal to 3. It's not possible. Wait. 10. It's not happened. Some constraints are there. This is half of 5.16. 2.58. And then this is 42, and here I am drawing sorry. Okay, here I am drawing a line with a 3 dimension. So here it is 3, here it is half of 5.16, 2.58. Then draw a line connecting these two. So it's actually a tapered one. Then we can revolve. We have a revolve feature. Revolve. So select, sorry, forgot to give the center line. So edit definition. We have to give the center line also. So this is my center line. Then only I can revolve. Then so we give the center line. Then we can remove. So see this about the center line. We revolve, and this is actually a tapered one. See this. This is the higher end, and this is the lower end. We save the components. So we finish all the components. Then we are going to make an assembly. So in this, here this is the assembly, and this is knuckle join. And here again I am using the same template for assembly. So this is the assembly window, and in this window here using this icon I can retrieve the components. So from the desktop, first I am calling fork and open. So this fork end actually, here also we can give the plane also. So this is the plane. Okay, we finished. Press OK. First component is OK, now mating. And the second component I am calling is end. End open. So in this end, here I switch on all the. So I am going to make the center line of this center axis and center axis of this end. So here we can see the center axis of this end. So click on the center axis of the end, then click on the center axis of this fork end. So then the default one is distance, but here I am giving coincide. So here we can see some of the constraints are, the degree of freedoms are constrained, so it can move only in this direction, and the rotation. This rotation also possible. Here I am not constraining this rotation because in knuckle joint application some flexibility is allowed for this rotation. So I am not constraining this rotation, but we have to constrain this movement. For that, select this plane and the inner plane and give the coincide. So automatically select as coincide. So it's fully constrained, but we provide some rotation. We are not remove the rotation degree of freedom. Rotation is possible between these two components. Then press OK. So we made the second component. Then third one. Is the pin. So here again, this pin also we can made with the axis. So select the axis of this pin and select this axis, and here again coincide command can be used. So here we can see the pin is moved, and this movement and rotation movements is only possible. Okay, so here I am rotating. Okay, so we can constrain this rotation by means of selection of this center axis and the center axis of this shaft. Okay, and make this as parallel. Okay, parallel. So thereby we can remove this. See this rotation is arrested. So only possible movement is this one. So that is also arrested using coinciding these two planes. I am giving coincide. Sorry, it's reversed. So we have to remove this. To remove any mating, just click on here, double click on here, and remove these two matings. Okay. So this movement is possible, and by removing this is also removed. So again we can create a parallel mating. Two components oriented, this changes to parallel. Okay, then this is, we have to give the constraint for this. So select this plane, select this plane, and this select it. Maybe so this plane, and sorry, pin edit definition. Some problems in this parallel mating also. The parallel mating is removed. So here I am selecting to give the parallel. It's not coincide. Coplanar, but it's not plane. Okay, leave it. First we will arrest this movement. For that, again I am selecting this one under this surface. This is not parallel, coincide and waste. So we coincide that. This is already fully constrained. Let me check. Sorry, it's already coincide that fully constrained. Stands to fully constrained, so we cannot change this. So we have to remove this again, because when it fully constrained, we cannot do any other mating. So initially we have to do this mating. We have to arrest this. It's not a compulsory one. It's okay, but proper positioning. So we can select perpendicular. Oh, okay. Always it will be perpendicular. It's better this one. This and the axis of this one. It's not orient. This is parallel. Now it is parallel. Next one. Then it will be coincide. the reverse direction. Okay, it's fully constrained. This coincide here in between these two faces, and this axis and this axis are parallel, and these two axes are coincide. It's fully constrained. Okay, then again retrieve collar, open collar. So I think the dimension is different. Collar dimensions is changed. So this is the center axis. Can see the center axis of this column. So this is the center axis. That is again coincide. I think the collar dimension is changed. It's not problem. We can change the collar dimension. Then again the coincide this surface and this surface coincide, but we cannot. And one more thing is that we have to make some hole on the collar also. So we completed the assembly. It's not possible. It's not. Then after during the assembly also we can edit the components. Just to go here and right click, then edit. Activate. Edit definition. It's not edit definition. Then edit reference pattern. Open. So this collar is open. Here we can edit any editing will be automatically reflected in the assembly drawing. So some dimensions are different in this collar. Its dimensions is 536 and 24. It's 536. I think this is 36. Actually that was the radius. This is actually indicating the radius. So this is the collar. Okay, so this is the collar, and again we have to give a hole through this collar. For that, select the planes. One plane will be passing through the center. Here this plane is passing through the center. Sketch. Then make all these things are reference. Then draw a circle. The circle diameter is our 5.16. That is the diameter of the smallest diameter of the taper, 5.16. Enter. Then remove these lines. Okay. So we have then two side, remove material, and the collar is 36. So here we give the distance 36. So you got a hole here. Then just to save here, color, okay, then close. So it's automatically, you can see the hole. So it's automatically change in the assembly view. Okay, but the hole is not, we have to edit this mating. So edit definition, we do remove, because the hole should be visible. So that is also, that is okay. So we have to, rotation is possible. Before this, we have to give the axis coincide. So I remove all the constraints, then take this out and give the first constraint is this one, the center axis and the axis display. The center axis of this one and the center axis of this collar are mating by coincide. So we got the first. Then second one is this one. The center axis of this hole and this hole should be coincide. So then is fully constrained. So we can see the hole. Okay, we can see the hole here. Then through this hole we can insert the pin. Taper pin. Open. So it's a very simple, just to coincide the axis. Then select this face and select this face. It's not tangent, and we can it's only possible, tangent is only possible because this one of the face is a curved face. So we have to remove this and select any other. So we can give the distance. So for that we can give this face. And we give distance. Some problem. Remove all the constraints. So first constraint is the axis constraints. Axis is not visible. Both are coincide. Both axes are coincide. It's not coincide. So this axis and this axis coincide. Okay. Then we can give this plane and select this plane and make a distance think some distance. So by providing distance we can constrain that, but distance is not specified. So I think the computer is slow, that is why it is not moving. Remove this again, retrieve the taper pin. So it's very simple mating, but the computer is slow, that is why it is take time. So take the center and take the center of this and give the coincide command. So both are coincide. Then give this surface and this surface, give distance. So okay, now it is okay. Then just drag through the hole. Okay, this is okay. Okay, the two ends are visible. Then fully constrained. So this is the assembly of the Extrude. And after the assembly this is the isometric view, standard orientation, and better view is this type. Okay, then we can do exploded view. For that, here we have an option exploded view. So by touching the exploded view, then edit to position, give edit to position. That is a taper pin. Okay, taper pin. Okay, this is the edit the position again. Taper pin, we have to move the taper pin. This is actually should be in the sequence of how these components are assembled. Okay, anyone should understand how these components are assembled by looking on this exploded view. So it should be clear. So just by moving this IN here, pin in downward direction, collar here, taper pin here. So this is the exploded view. Okay, then just click. Okay, so see this. This is the exploded view of the final assembly. Then we have bill of materials. See this bill of material. And actually here we have 5 components, and how many quantities of these components are used for this assembly, and what are the name of these components, and all these details will be available from this assembly. In a company, for example, while manufacturing a car, there are thousands of components. So the entire details of these components, quantities of components, etc. will be available from this bill of material. So just click top level or sub assembly, we can select it. Then click OK. We will get the Extrude. So in this knuckle joint we can see there are 5 components and the quantities are single. Each components are only 1 unit, and by clicking on this we got corresponding file. So this is the bill of material of the knuckle joint. So by this way we can create the bill of material, and this is the explorer view, and we can change the appearance using this tab. Different colors we can provide, and that is about this assembly. Then okay, I think I finished everything. It's not needed. Okay, then we can create the drawing based on this assembly. For that, new, then drawing. Again you can use the, so this is again knuckle joint. Drawing. Okay, re-enter. So here also we have to give the space. Okay, then landscape we can create. Already explain what is the we can use any templates or empty sheets. We can create the drawing. Here I am using a template. Use template. F4 drawing. It's okay. So this is the drawing, and if you want you can create the drawing with the according to your style. For example, create drawing with the empty landscape, then press OK. Then here you can create drawings, and click general, not combined, OK. Then click the left mouse button. If you want to position here, click here, click here, left mouse button. So first you click general, then non-combined state, then left mouse button at the position. Then we can see the front view. Apply, and we can scale also. There are different options are available here. Custom scale, we can give 1. Apply, close. Then again general, then top view, scale. Sorry, first we have to apply the top view, then scale. Here also I am giving 1. Apply, close, general. Okay, side view, front, apply, scale, custom scale is 1. Apply, close. And if you want the isometric view, then that is also again add here. There are different types of views are available. trimetric view, isometric view, user defined views, etc. And here also we can scale. Here I am giving 1.5, 1.2. Higher size. So close. Okay.